All right, let's get to it. Let's solve this problem. Remove the element. It's your boy Kane from the Kanologist. He's like technologist or scientist, engineerist, and then you put Kane in there, and you get Kanologist. But like, I didn't want to go like Kane-ientist, because like scientist, because it doesn't sound as cool. You know what I'm saying? So Kanologist sounds pretty cool because of like technologist. You know what I'm saying? Let's see. Okay, equals 1. So we got to sort this thing in place like the last question. Basically, you get an input array, you get a value to remove. It expects an answer with the correct length. So we got to do whatever we got to do in place. And then it says, let's look at the example, 3233. So 2 is not equal to 3. So basically, like the last question where you have to kind of sort and remove duplicates, this one's like basically sort, but you're not really sorting. All you're doing is just moving the numbers that aren't the value in the front, and we don't care about what happens to the rest. So at the end you get k equals 2 for 1, 2 values. Okay, let's try it. For I in range 0. The length numbers, boom, let's change that to 1. Yeah. Let's see, if is not equal to value, or let's say if it is equal to value, then we want to go for nums I minus 1. So if nums I is equal to nums I minus 1, so it's equal to nums I minus 1, I equals k. So we can go it's equal to the value. Let's say let's start at 0. Now 1, 2, 3, k equals 1. Well, let's say nums I equals the value. So if nums I equals the value, let's just start at 0. And we'll make k 0. If nums I is equal to the value, I want to swap. If it's not equal to the value, I want to keep moving on. So if it's equal to the value, I want to go num. What I could do here actually is this. If No, so I'll leave that. I'll start at 1. If nums I equals val at 1. Nums k equals no, if it's equal to the value. If it's not equal, okay, if it's equal to the value, I want to swap. If it's not equal to the value, I can move on. So if it's equal to the value, nums k stays the same. Yeah, if it's equal to the value, nums k stays the same. If it's not equal to the value, nums k is equal to nums I. So 0, because we'll start from the beginning. Nums k equals nums I if it's not equal to the value. So if nums I is not equal to the value, nums k is this. And we're just making nums k the index. So basically, k plus equals 1. Return k. Let's try that. I just want to see what happens. Oh, you gotta put a colon here. Let's try this. Let's see what happens. Okay, so basically this is correct. Let's try submitting it now, and then we'll go through the logic. Boom! I am a freaking expert. I'm like the smartest guy in the world. Well, I'm playing because it's only an easy question, but you got to go through my logic, right? So we have to understand what's going on. We want to sort the array in place. So we can't make a new array. That's why you're like, oh, okay, why can't we just make a new array and then just go through all this and just stuff it in? Because we have to do it in place. That's the requirements here. If you go to this, you can go nums length could be 0. So you can't default k equals 1. Because if you have an array length of 0, k equals 0. Right? And then if you have, you can have numbers going up to 50 in value, and then the values can go up to 100. So the value can be from 0 to 100. The numbers values from 0 to 50. And then the k length, so length of the array could be from 0 to 100. So if it's 0, k, we return 0. That's our base case. Then we want to sort it in place. So basically what happens is k is our new index. We could keep it at 0, right? If the first element, so I equals 0 and k equals 0, if the I is not equal to that value, the target value, then I just make I the new k. So k equals I. So nums at 0. So nums at 0 is the value that you just looked at, because now you're going through I, right? And now we increment k by 1. All right, so that's one element. Boom. Now we go nums I equals another number, right? So let's say it's 3. So let's say the value is 3. Let's go through this. Let's go through this actual example. Right, so let's go through the actual example. So the value is equal to 3. Value is equal to 3. Let's start with our code here, right? Because this is O of n time. You're only going to traverse the array one time, and it's O of one space because you're only taking one element. The space doesn't increase with the number of elements, or it's not proportional to the number of elements. It's always going to be k as your memory slot. So let's look at for I in range 0 to len nums, right? So right now, let's look at this 3, 2, 3, 3. Let me just comment that here. 3, 2, 2, 3. All right, so first we're on range I. So nums I is 3. Is nums I not equal to the value? If nums I is not equal to the value. So right now nums I is equal to the value, right? So nothing happens. We go on to the next number. So now we go on to k equals 2. I equals 2. So I was at number slot 0. So now we go to index 1. That value is 2. So here, this 2 value, if nums I is not equal to the value, so the value is 3. In the previous one, it was 3 as well, so it matched. So we didn't do anything. This time it doesn't match. So now we have to go nums k. So k equals 0. This number here is equal to nums I. So it's equal to 2. So now we make this basically, let's just say, let's comment it, and then we're sorting it in place. So k is still, basically k is indexing your new array. So this 3 now becomes a 2. So k at 0 is 2. And then we go k plus 1. Because this 0 element is taken. So now anything we add to the array now becomes, takes this slot. So now we go to index 2. Boom, 2 again. 2 is not equal to the value. So nums I is 2. And the val is 3. As shown here. So since 2 is not equal to 3, nums k equals nums I. So k at index 1 is 2. Boom. Now we increment k again. 2. Right? Now we go to nums I equals 3. So 3 is equal to the value. So it's equal to the value. So nums I is not equal to the value. So this doesn't happen because nums I is equal to the value. So now we exit our loop and we return k equals 2. So your function should return k equals 2 with the first 2 elements of the num being 2. Does not matter what you leave beyond the return k, hence they are underscores. So I return this basically because all I'm doing is swapping the 2 and just keeping track of the index of k. So let's see, change the system. First k elements of nums contain the elements which are not equal to val. The remaining nums are not. Return k. So return an integer, given an integer nums. Remove all occurrences of val in nums in place. The order may be changed. Return the number of elements which are not equal to val. So the number of elements is 2, right? But the way we're strategically using it is we're using this to give us the number of elements, and we're using it sort of like an index. See what I'm saying? And because we incremented it here in that last one, the index of k is actually still going to be 1 here. So 0, 1. Because we incremented it here and there's nothing left to traverse, we just return k. So we kind of use it as a killing 2 birds with 1 stone. We use it to track the index, and we use it to track the number of occurrences where you don't have this value. So that ends it for this problem. If you liked the content, please feel free to send me a like, subscribe to the channel. If you have any feedback for me, I'm right now working on getting a better camera. As you can see, the video quality is kind of shit. My mic is decent, but I will be reinvesting into getting better equipment so I could provide a better experience for you guys when I'm solving these problems. And yeah, like hopefully I can make things clearer, and appreciate any feedback you guys have. Thanks for watching the Knologist. Yeah, once again, drop a like and subscribe.